All right, here's a good application of quadratic function. So they say stone thrown downward travels where this function here tells you how far it's gone. That's the s of t for any time t. So they say if a stone is thrown downward at 39.2 meters per second, that's where that number comes from a height of 318.5 meters. So that's the height, that's the s. So s of t is a distance in meters. So if I were to rewrite that equation, so s of t, 4.9 t squared plus 39.2 t. So they're saying this needs to be replaced with 318.5. Okay, so replace that. And then, since it's a quadratic equation, I want to make it equal to 0. So subtract 318.5 on this side and subtract 318.5 on this side. So I'll have 0 is equal to 4.9 t squared plus 39.2 t minus 318.5. And I have to solve that equation. It'd be nice to be able to factor that. I don't know if you could factor that one. I'm just going to give it a shot, but I wonder if you could divide, because it'd be nice to have a t squared and nothing in front there. I wonder if 4.9 would divide evenly into all of those numbers and divide 4.9 over here. Let me get my calculator and just see if that works. Okay, so 39.2 divide 4.9. Whoops. 4.9. Oh, it comes out to 8. That one's 8. Whoops. That one's 8. Okay, how about 318.5? 318.5 divide 4.9. Comes out to 65. Interesting. Whoops. So, what did I say? 65. So when you divide those, that one comes out to 1t squared. This would be 8t minus 65 equals 0. And I think that was just a fluke that it came out exactly even. If it didn't come out even, what you could do is just use your quadratic equation. Plus or minus b squared minus 4ac all over 2a. And you could do that on the calculator. And so a would be 4.9, b positive 39.2, and c a negative 318.5. So you could plug those into the quadratic formula too. Or you can factor this one. I think this is 13 and 5. So t plus 13 and t minus 5 equals 0. So according to the 0 property, I can say t plus 13 is 0 and t minus 5 is 0. So here t is equal to minus 13, or here t is equal to 5. So they say, how long will it take the stone to, what was it, hit the ground? It would be 5 seconds. Here, this negative 13 for a time, it wouldn't make sense, so I wouldn't use that. So this would be my time. Now, another way you could look at that is you could look at it in terms of, and I'll go back to this equation right there. You could look at it in terms of graphing. So if I were to take and graph that, so I'm going to graph y is equal to 4.9 x squared. I use this x's instead of the t's, just because the x is there. I think decimals will allow you to use both, but 39.2x minus 318.5. There we go. So this green line here, there's the green line. There's the quadratic function. And the solution is, when does it hit the ground? Well, the ground will be this line right there. So all I have to do is find on the graph, I don't know if I'll be able to do this. Yeah. Oh, I've got that line in the way. Just a minute. So on the graph, I just have to tap on that point, and it'll tell me what those x-intercepts are, or where it hits the ground. So it hits it at 5 seconds or at negative 13 seconds. And again, I wouldn't use the negative 13. All right, hopefully that helps with that question. Is that actually the right answer? Let me just see. Oh, yeah, 5 seconds. Okay, hopefully that helps.